Hello dear students, our next derivation number 21, it is combination of cells, equivalent EMF, series combination. So we are going to derive a formula for equivalent EMF when two or more than two cells are connected in series. Okay? So we'll do this for two cells and then we'll extend the formulas for n cells. So this is a setup that two cells E1 EMF and E2 EMF, their internal resistance are correspondingly R1 and R2. Right? So this is how we have set this up. Our intention is to replace these two cells with an equivalent EMF cell and an equivalent internal resistance cells. So if I replace these two cells with a single cell, it should behave like this combination. That is what we are intending to do. Okay. So let's assume the current flowing in this setup is I. Okay. We are not really bothered where this current is coming from. This is just a part of a circuit, right? So we are just concerned with this part. So I can write here, if I take these 3 points A, B and C, right? So I can write VA minus VB. The potential difference between these 2 points will be what? E1 minus I R1, E1 minus I times R1. Simple. ऐसे ही मैं यहाँ से यहाँ अगर जा रहा हूँ तो VB minus VC क्या हो जाएगा? It will be E2 minus I R2. Even see yourself. E2 minus I R2. If you add these two equations, VB and VB will get cancelled. You'll get VA minus VC as E1 plus E2 minus I times R1 plus R2. Now, if you are intending to replace these two cells with a single cell, like this, so what you should have, VA minus VC should be E equivalent minus I times R equivalent. I forgot to mention the current here. This is the current I. Right? So it will be E equivalent minus I times R equivalent. Now if you compare these 3 and 4 equations, 3 and 4, right? If you compare these 3 and 4, what you will get? E equivalent will come as E1 plus E2 and R equivalent will come as R1 plus R2 just by comparison. So E equivalent की जगह आ गया E1 plus E2 and R equivalent की जगह आ गया R1 plus R2. So this is what it is. Now, okay. There's one concept involved here, so I would like to tell that I've told in the offline classes as well. Now this combination, if you notice, this is not a series, this is rather anti-series. Means though it looks like series, but you have connected the negative to the negative of the second cell, which is typically not the case. Whenever we connect the cells in series, the negative of one goes to the positive of the other, right? So if you connect like this, the same formula will become E equivalent will be mod of E1 minus E2. It means whichever is bigger, right? You are more concerned with the difference. It will become E1 minus E2, but R equivalent will remain same, R1 plus R2, right? And this can be extended for n cells. For n cells, this can be extended. R equivalent can be written as R1 plus R2 plus so on and so forth plus Rn, and E equivalent can be extended as E1 plus E2 plus so on and so forth plus En if you have n cells. So this is the formula derivation for equivalent EMF and equivalent internal resistance for a combination of cells in series setup. Thank you.